Am I live?
Okay, next we have Ellen Shapiro from USA. She's very funny and a very great inspiration for me and for everyone. So please, guys, welcome Ellen Shapiro for with our talk.
Grazie, Stefano. Let's see. You guys see my yeah, there we go. It's on there. So I'm delighted to be back at Swift Heroes, although I'm sad that I am only virtually in Torino rather than doing what I did the last time I was there and eating a ball the size of a grapefruit of super fresh burrata cheese, because it was amazing. Anyway, I work for a company called Apollo GraphQL, building and maintaining their iOS SDK. And when I tell people this, people generally have one of two reactions. They're either insanely excited because they're already bought in on GraphQL, or they're wondering what on earth GraphQL is, either because they haven't heard of it, or more often because they have heard of it because it's a tech buzzword, but they don't actually know what it is or what it does. So this talk is more for that second group of people. And I want to go back to the very beginning and start with a super basic question. What is a graph? For the majority of the population, when you say graph, they think of something like this, where data is being visually displayed on labeled vertical and horizontal axes. And those kinds of graphs are cool, but the more relevant question is what a graph is in the context of GraphQL. When we talk about a graph in GraphQL, we're talking about a mathematical concept called graph theory, which has also been brought over into computer science. So the basic concept in computer science is that graphs are used to represent networks of communication, data organizations, computational devices, the flow of computation, etc. Okay, you all did not just come here to listen to me read you Wikipedia as you desperately fight to stay awake. So let's take a look at a couple of more concrete examples of graphs. The first kind of graph is email. Each email is represented by a circle, but each circle also, other circles represent people that are senders and recipients. And the ways that all these emails and senders and people and recipients are related represented by these lines. But if you look closely, you'll notice that these aren't really lines, they're arrows. That's because in the relationship between a sender and a recipient, or a sent email and a reply, there's always a direction that things have to go. And this, unsurprisingly, is called a directed graph. Another kind of graph you may be more familiar with is something like Facebook or LinkedIn. Each person has to agree to connect to the other person. Then once that connection is made, things can go either way between the two people. And this is called an undirected graph. And you can see that both kinds of graphs have two general things in common. The nodes are individual pieces of data, which in both diagrams, which were represented as circles, and the edges, or the relationships between the pieces of data, which were represented by the arrows in the directed graph diagram and by lines in the undirected graph diagram. And particularly for those of you who have previously done a lot of work with core data or other relational databases, this may sound a little bit familiar. This looks just like the entities and relationships within a core data database, and clearly there are some similarities. But does that mean a relational database is a kind of graph? Well, there's some important differences. The biggest of which is where the focus of how data is structured lies. In a relational database, the focus is on the nodes, and relationships are somewhat secondary. And this is something that core data actually completely abstracts away for you, but you can see if you compare the entities, which in this little sample are a launch, a mission, a rocket, and a user, with the underlying SQLite database that's created by the core data. You can see those four entities get their own tables in the database, but there's a fourth table before you start getting into the Z underscore tables that only handle metadata, and that's the passengers table. And if you look back at the core data diagram and try to figure out where passengers came from, you can see that it's one of the sides of the only many-to-many relationship in this model. So while core data itself is capable of glossing over relational database relationships, those databases themselves are focused only on single relationships, not many-to-many relationships, and certainly not traversing relationships over and over and over. This is instead what graphs are focused on. How is the data you have related to the other data you already have? And how can you traverse that data to find data that you want? For example, if you have a social graph where each person has information about various relationship edges and person nodes, you can do things like request the user's father's best friend's oldest child's middle name. Now, how do we find out about those relationships? What are the nodes that are available to you and the edges that you can follow in the graph? The answer is GraphQL, which I'm sure, given the topic of this talk, is a huge surprise. And the QL there, similarly to SQL, stands for query language. It's a way to ask the graph about what it's got. So now that you know what GraphQL is, you might be wondering, how do I actually use this thing? How do I find out what to query and how do I query it? And I'm going to be giving some examples using Apollo sample server, which is the result of our full stack tutorial, and which gives information about various SpaceX launches and allows you to pretend to book a trip on one of them. So the first thing to understand is how GraphQL tells you what you can ask for, and that's through the schema. The schema is a definition of every node available to you and what properties it has, including properties that are essentially other objects, meaning that there's a connection between them as an edge, as well as what operations are possible. The basic thing the schema does is define what is possible to ask for, written as a sort of contract. What are the things that are in a query? And the schema is often written in a language called schema definition language, which is pretty similar to TyPESCRIPT, which is a thin typing layer on top of JavaScript. So here's part of the schema for our sample server, which again lets you learn about SpaceX launches and pretend to book a ride on one. And one thing that you'll notice real quickly is that this part of the schema is all about defining types. And this is where Swift developers get really excited because we really love the ability to have type safety. There's no more question of what type a particular item is going to be when you get it back from the server because there's a defined type that it should be. And if that's going to change, then the schema itself would need to change. Now, you don't want to go around creating types out of absolutely nothing. So you'll notice that there are a few common types that, not coincidentally, line up pretty well with what you can get from JSON. And these are called scalar types. And they're basically the base level building blocks of the system. You can build types out of these scalars, and then out of those types, and then out of those types, and you can have a fairly comprehensive type system pretty quickly. Now, one thing I do want to warn about is how optionals work with GraphQL, which I'm going to do in the form of a pop quiz. So I'm sorry if this gives you flashbacks to high school. The question I'm asking is the following type optional? And the type is string with no annotations. And the answer, of course, is that it depends on whether you're using Swift or schema definition language directly. Now, you may think that I am trolling you because it depends is a horrendously senior developer answer, but the fact of it is that there's a difference between Swift and GraphQL when it comes to optionals. In Swift, if you want something to be non-optional, you just write the type name with no annotations. For GraphQL, the way you annotate something as non-optional is to give it an exclamation point. And I know you good Swift developers are slightly horrified by this since you've been well trained to run screaming from force unwraps. But the reason for that is that in GraphQL, types are designed to be nullable by default. So you need a different kind of annotation to indicate that a particular item is not nullable. So you're going to have to get used to that exclamation point not being wrong. So now, if you do want something to be optional, in Swift, we have our good old trusty question mark, indicating, well, we're not sure if it's there or not. And since things in GraphQL are optional by default, that means optionals in GraphQL have no annotations whatsoever. And particularly as a Swift developer, this is annoying to deal with. But at a certain point, if you work with it for a while and or have a big enough glass of wine, it basically makes sense. Now, once your types are defined in the schema, it's time to define what operations you can actually do with them. This is basically defining where you can start getting into the graph. And there are three types of operation in GraphQL. A query allows you to say, please give me this data. In the case of our sample server, you can get information about launches in general, a specific launch, the current user, and how many trips have been booked in total. A query is by far the most common type of operation, to the point that the words query and operation are often used totally interchangeably, even though one is much more of a subset of the other. And this is true even in Apollo's docs, which we are working on fixing. but it's a very, very common thing throughout the GraphQL ecosystem, so it's worth being aware of. The next most common type of operation is a mutation, which allows you to specify how you would like data to be changed, and then gives you back the result of that change. In this case, you can book or cancel a trip, then receive a typed response in return that you can then get whatever information you want from. You can log in, you can get an auth token as a string, or you can upload a profile image and get information about the current user in return. These are all one-shot deals. You ask the server to make the change, it makes the change, and then it gives you back what you want. If you want something that updates more often, you want the third type of operation, the subscription, which allows you to be proactively updated when data changes on the server. Under the hood, this is generally implemented through WebSockets, though it doesn't necessarily have to be. Speaking of doesn't necessarily have to be, subscriptions are a really cool trick, but you need to be careful because not every server provides the proper support for them, and you can really get yourself into trouble if you are not careful. So now that you know from the schema how things are related to each other and what you can ask your server for, it's time to actually learn how to ask for it. So we're going to start with something that's actually baked into almost every GraphQL server, and that's a tool called GRAPHIQL or GRAPHIQL. Nobody really seems to be able to agree on how that's pronounced. But for the purposes of what we're doing today, let's call it GRAPHIQL. On almost every GraphQL server, when you load up the GraphQL URL in a browser, you'll see this page or something like it in dark mode, because dark mode is awesome. And you'll see on the right that there are a couple of tabs, one of which shows the schema itself, and the other of which shows the documentation that's generated from the schema automatically. Next, we'll move up into the upper left section and look at how you actually write an operation using GraphQL. The first thing that you have to do is declare. This is, in fact, a query. That way you are distinguishing versus a mutation or a subscription. Next, you can add parentheses to allow you to pass in a variable. The bit with the $sign prefix is the actual name. The ID is the type. And again, the exclamation point is saying that this is a non-nullable type. Next, you can start making the query. Now, remember, there's a list of possible queries that's defined in the schema, and this is using one of them. The unannotated ID is the parameter name, and the ID with the $sign in the query is in front of it is the variable that you declared above. And you can see from the query definition that the type return will be a launch. So you can use the definition of the launch to see what the properties of the launch are and then access them through that level. Finally, you can look at the properties of the custom types like mission and rocket and use those to pull out whatever properties you want of those types. So now you've got a whole query, and you're probably wondering how to pass in the parameter that was outlined earlier. Well, in GRAPHIQL, the answer is that there's a little section below the query section where you can specify variables in a dictionary. And in this case, there is a secret. ID is a type alias for string, so you do need to pass the identifier as a string. Next, moving back out to look at all of GRAPHIQL, you'll see that big old play button right in the middle. And now that you've got a written operation along with the parameter you're passing in, you can just smash that bad boy to actually run the query, and you'll see the result pop up in the right-hand panel. Now, one thing I want you to take particular note of is the shape of the response. The JSON that's returned matches the shape of the query absolutely identically, along with the names of the properties in JSON. By creating a query in a certain shape with the field names prescribed by the schema, you can know exactly what your response is going to look like. Now, I want to take a brief detour here to ask, how would a REST endpoint do this? Because this is one of the major things that drew me to GraphQL in the first place. And I want to compare the way you can do this with GraphQL to this REST endpoint from the open source RSpaceX API, which allows you to use REST to get data about a specific launch. And when you call a get on that endpoint, you get literally everything you could ever possibly want to know about the launch. I had to zoom GitHub way out to even be able to get a screenshot of this response to JSON. And really, if you're only going to be using the mission name and the rocket name, that is way too much stuff. With REST endpoints like this, you're going to waste your users' networking allotment and battery time on a whole ton of data that you are immediately going to drop on the floor. With GraphQL, you're able to get exactly the data you need and only the data you need. And frankly, that's a lot better for everyone. And if you decide when you look at the response, you know what, I don't like the name of this field called site, I want it to be called something else, you can actually do that really easily by doing something called aliasing, which allows you to change the name of the field that's returned to you. So that's pretty neat. So now that you've got a schema that defines what's possible to ask for, a query that defines what you're specifically asking for, it's time to do some validation. So are you going to tell your code that it's awesome so that it feels better about itself and it builds on the first try? No, you are not. Validation is the ability to compare your operation to your schema and find out before you even lift a finger if what you're asking for is even possible. So GRAPHIQL is real nice about this. It allows you to get an error message that tells you why something won't work immediately as you type. But what if the same thing that powered this could also validate, maybe not as you type, but could validate GraphQL operations that are in your Xcode project? And once your operations were all validated, you had enough information with the types that are defined in the schema to generate all the code necessary for doing all of this in Swift, including the parsing code. And that is where the Apollo iOS SDK comes in, and that is maintained by some smirking doofus. Wait, I'm told that that is actually me. Now, one thing to be aware of that's specific to Apollo code generation is that this query we've been working with so far is called an anonymous query because it doesn't have a name. In order to generate code that works with this query, we need to give it a name. And I'm going to show you what we do with that name in a version of our generated code that essentially leaves out a bunch of the messy stuff we're doing under the hood to make all of this work right now. This is also hopefully going to be much more similar to how this will work once some ongoing work on the code gen is completed. So here's the nested class and structs that are created for the operation that we've been looking at. The operation was named launch info, and it was a query. So the code gen automatically appended the word query to the end of it to make it clear the class name of what we're doing. The parameters name and type are both pulled from the query's declaration so that you can call this like a normal Swift class. Next, we have a nested class called data, which holds the parse response from the server. Now, you may be wondering why the return value here is optional. If you look at the definition of the query, you'll see that launch is unannotated, which means it's optional, which makes sense. If someone were to pass an ID for a launch that didn't exist, you'd want the server to be able to return null for that. Anyway, that launch is of a type that's nested within launch query info and data. So why is it nested? Because it contains only the properties that were asked for in that specific launch info query. There are other properties on launch, but after all, these are the ones that you asked for. You can't even try to access the isBooked property on this launch object because even though that's a property that exists in the schema, it's not a property you got info for with this request. This helps you really easily figure out when you need to add new fields to your query. If you need a piece of data and it's not on the object, you need to add that field to the query. And that's the same reason that the mission and rocket types are nested as well, to allow that level of granularity. And the best part of all of this is that you do not have to write any of this code. Apollo iOS will generate it for you. And that's the case for every single operation that you hand us. The more stuff you switch from a REST endpoint that you're building out all the boilerplate for yourself, the less boilerplate that you have to personally write. You also don't have to write a URL session wrapper that properly formats everything to send to your GraphQL server, and then parses the return values out of JSON into these generated types, because I just spent the last 2 months rewriting that feature to make it more robust. You're welcome. So now there's not a way for me to write everything that you need. You are going to have to write some code. And this is what it's going to look like. You have an Apollo client instance that you can use to do operations. You hand it your constructed query, and it goes out to the network, and it gets you a Swift result, which, like any Swift result, you start by switching on to see what you've got. And here, if you have a failure, it's generally either something that happened at the URL session level with loading or some kind of parsing error. And you can handle that error however you want, probably by doing something better than just printing it out. In the success case, you actually get a GraphQL result. Now, that seems a little excessive. You know, you got a result that contains a result. What? Why is that? Are you exhibit? The answer is that GraphQL allows you to return partial results when part of a query works, but another part of it didn't. So imagine in our world here that you're able to get most of the information about the launch, but for some reason, the data for the rocket couldn't be loaded. And importantly, rocket is a nullable property. In that case, you get both an error about why the rocket couldn't be loaded, maybe the microservice that deals with rockets is down. And you'd also get the rest of the data that you've asked for since it was possible to get it. Now, this optional chain leads me to a quick pro tip, which is that you can use Swift extensions to allow you to handle nullability gracefully from the final call point. Now, you'd have to add this outside of the generated API files, which are constantly overwritten. But you can add an extension that turns a nullable property into a non-null property really easily, or moves things up to a higher level for better readability. Now, that's really getting down into the nitty-gritty of how to use things. So I want to zoom way, way back out for the rest of this talk, because now that you know how GraphQL works, it's probably helpful for me to outline what GraphQL is really good for. And I've already covered a big piece of this, which is that you can much more easily get the data that you want, and only the data that you want, and not the data that every single application that would ever want to use a specific endpoint ever needs to have. Another benefit of this is that you can, adding stuff to a graph is much, much simpler than adding things to a REST API. And I have had this experience quite a bit personally, and I suspect so have you. There's a field that's available publicly on one endpoint, but I need to access it on a second endpoint. So I say to the backend team, hey, can we add this field that's on endpoint A to endpoint B? And the backend says, sure, we'll put that in the backlog. And then there's some kind of site emergency, and the project manager prioritizes a new feature that the CEO wants, and it takes a month or two just to add a piece of data that's already available in public to a different endpoint. And you feel like you're going to die. With GraphQL, anything that's available in the schema can be accessed by the relationships in the graph. If you remember this example, the graph here only has to know that a person can have a middle name and that each of these relationships are possible. And you have a way to tell which of these relationships are optional and which ones are not. Adding something to the schema means it's available everywhere in the graph. You can traverse it to it, given the relationships between the pieces of data. So those are some pretty compelling pros. I want to also talk about a few of the known cons, because GraphQL is a pretty sweet hammer, but not every problem is a nail. And it doesn't mean that the GraphQL community hasn't tried to make the problem a nail, which is the case with uploading files. Because GraphQL is designed to send much smaller bits of data around, the community came together with a standard that has a specially named type that allows you to create a multi-part form request to upload a file with a mutation that can replace various temporary null parameters with the uploaded file on the server at runtime. And the problem, as with all mad science, is that while this is technically possible, it's really a stretch to say that the uploading itself should be part of the graph. And it's super, super error prone. A much better way to handle uploads on GraphQL is to continue to use whatever method you're already using to upload files, whether it's just a REST call or using something like the AWS SDK to upload to a specific bucket. And whatever you're doing should return the URL of where the uploaded file will live. Once you have that, you can send that to your graph as a string much more easily, and you will have way, way fewer problems in your life. Another thing that's not a huge advantage of GraphQL is working with highly optimized queries. This is when your backend has tuned the hell out of everything, removing every unnecessary field, shaving every millisecond off a database call that they possibly can. In that case, REST can be faster. Now, there is a lot of tooling around GraphQL, including a whole bunch that's made by Apollo, both free and paid. And that helps you figure out where bottlenecks are in the actual requests that are being made and executed here. While you can use that to find bottlenecks, you can't completely eliminate them and still have the kind of flexibility to allow people to request whatever they want. This is absolutely a trade-off, but it's a trade-off that's worth being aware of. Speaking of trade-offs, while adding stuff is way easier with GraphQL, it's much harder to completely remove things. Because while the ability to easily add things to the schema and the availability of anything in the schema to anything querying it means that versioning isn't necessary, it also means that version isn't really meant to be done with GraphQL. So how do you remove things? Because there may be clients that are relying on fields in the schema that can't be changed. You always have to start by deprecating the fields before removing them from the schema. And Apollo iOS takes that deprecation annotation and adds a warning for you when you're using a deprecated field to try and tell you to stop doing that. But your server team still has to look at actual usage after something's been deprecated and wait until nobody is actually asking for that field anymore before saying goodbye to that field. The good news is that it's much, much safer for clients. The bad news is that just removing something that you're like, well, we're not going to do this anymore, becomes this whole procedure. Another thing that GraphQL isn't always good for is keeping your security super simple. And you may have already guessed this, because when I say that if you have access to a graph, you can ask for anything on it, developers get really, really, really excited. But the security team tends to be somewhat horrified, because if you're used to just being able to slap a 401 unauthorized on any endpoint that needs to be protected, the fact that GraphQL only has one endpoint means that you are not going to be able to just return that kind of status code willy-nilly. You're going to have to think on a more field-by-field basis about who should have access to what, and work with your backend team to make sure that works well for everyone. Oh, and there is one more pro tip. Schema introspection, which allows you to download the schema from a particular GraphQL server, is on by default, and it's unprotected by default. This means that anyone who knows the way to get to a GraphQL server to return information about its schema can get your schema really easily. You probably want to make sure there's at least some kind of API key needed to get that information, so that not everyone in the world has access to the shape of your data. So we have reached the part of the talk where I'm going to tell you what I told you in a way that tries to make you remember some of it. So first, a graph is a way of thinking about data pieces and how they're related. GraphQL lets you ask for information about what's in your graph and how it's connected, which is defined by the schema, along with your types and relationships between your pieces of data. You can then use operations to specifically ask for exactly the data that you need and receive only that data back. And finally, remember that as with any tool, GraphQL has a lot of stuff that it can do well. That's not literally everything. Be aware of its strengths and its weaknesses and use them wisely. If you're interested in trying out the Apollo iOS SDK, we have a tutorial available at this URL. And now I am happy to take questions, because I am massively under. Okay, check the questions here. Whoop. Thank you all. All right, and then I'm gonna mute myself. Let's see. Does anyone have any questions? Dario says, used GraphQL previously, you miss it a lot. You're welcome for the stuff. Yeah, let's see. Where am I on StreamYard? One thing that I can do, if anybody is interested, I can, let's see if I can stop sharing. And then I can share again. Share screen. All right, now we're going to be doing your entire screen. And now, hello, you see me staring at myself. So this is the full stack tutorial application, and I can sort of walk people through a little bit of what's happening here. Again, this schema is something that has a bunch of other things in it in terms of more advanced features, but the basic stuff that you can do is defined within this. And the nice thing is that you can get these pieces of documentation where the actual information about what you're getting back is included in the type. So you're able to look at what is, not just the type information, but the documentation gets rendered for every single type, which is pretty awesome. And then, yeah, like I said, you can make these kinds of queries really easily. Generally, you don't need any HTTP headers, and then these variables are right here. Let's see if there's any more questions here. Let's see. What do you recommend for the backend in order to start learning it? There's definitely some fairly easy ways to get it started with a bunch of node stuff. If you don't already have something, you can start with actually our sample backend. And I'm going to stop sharing my screen here. You can start with our sample backend, and I'll throw the link in there in a bit. Let's see. So yeah, you can start with that tutorial, and that just gets you started with a really basic node thing. And it is possible to use GraphQL with backends that have basically any language. And I think Apollo has a lot of hooks that allow you to basically say, okay, I want to call into the rest of my server, which is actually written in blah. So we actually have our backend stuff is actually written in Kotlin. So it's possible to have it be able to call into other things, then have those other things actually do the fetching that you need to do. We've been told that everything we get from GraphQL is optional. How or where can we change that? Schema. That is correct. Everything you get from GraphQL is optional by default. If the schema defines it with that exclamation point, then it is not optional. It's something where one thing that can be frustrating for iOS developers is that there are things that can theoretically be optional at some point, but they probably shouldn't be optional by the time they get to the iOS application. I think the biggest thing that I've seen be helpful in that occasion is, like I said, the Swift extensions, where you're able to just sort of say, okay, I'm going to do this handling over here, and be able to say, okay, this is how this actually winds up being. I think this is a good place to work with your backend to figure out, okay, do these things actually need to be optional, or are they actually required? And that's a place where you know, working with the backend as they develop that schema is really, really important. When debugging using Charles Proxy, as there's only a single endpoint, is there an easy way to rewrite responses from GraphQL for specific queries or mutations? Not that I know of. I think it's something where I've definitely used Charles Proxy to debug some of this stuff in the past. And it's something where you're hitting the same endpoint over and over again, but the information that you're sending to that endpoint is going to be different every time. In terms of like simple rewriting of it, I don't know of anything that's super straightforward for that. So that is a good question. Does anybody else have any other questions? I can also show off some stuff.
Hello?
Stefano's back. Hey, Stefano.
Hey, it's wasn't expecting this. Okay.
Yeah, I finished a little early. Sorry.
Yeah, I think we're going to wait for other speaker to do some kind